4NH3 reacts with the 7 molecules of O2 to give 4 NO2 and 6 H2O. So when 4 moles of ammonia gets consumed, at the same time 7 oxygen also gets consumed. So rate of disappearance of ammonia is here, suppose 4 moles, then rate of disappearance of oxygen will be also 7 moles, right? So 4 and 7. So which will disappear very fast? The answer is oxygen will disappear very fast. At the same time, when 4 moles of ammonia gets disappear, 4 moles of NO2 gets formed and 6 moles of water also appears here. But rate of formation of NO2 and water is also lower than rate of consumption of oxygen. So here the question is, which substance appears or disappears fastest? The answer is oxygen. Okay, so here answer is oxygen. Oxygen, the rate of disappearance of oxygen is the fastest here. Next question, fourth question. The peroxy disulfate ion H2O8-2 reacts with the iodide ion in aqueous solution via the reaction peroxy disulfate ion plus iodide ion, that is 3I minus, gives sulfate aqueous plus I3 minus aqueous. Okay, so we get sulfate ion here. So charge on sulfate is actually SO4 minus 2. An aqueous solution contains 0.05 molar S2O8 minus 2. That's the charge is minus 2. That's a peroxy disulfate ion. And 0.072 molar of iodide is prepared, and the progress of the reaction followed by measuring iodide ion concentration. The data obtained is given in the table. So this is the data. So what's the initial concentration of S2O8 minus 2? The answer is 0.05 molar. What's the initial concentration of iodide ion I minus? The answer is 0.072. And this data represent concentration of I minus. So when time is 0, concentration of I minus is 0.072, right? After time 400 seconds, the concentration of reactant decreases. That's I minus concentration becomes 0.057. So as time proceeds, the concentration of I minus obviously decreases due to progress of reaction. Now, first question here, they ask the average rate of disappearance of I minus between 400 and 800 seconds. Okay, that's the first question. So, average rate of disappearance of I minus. Okay, so I'll write here rate of disappearance of I minus. I minus is reactant, so that's minus sign, and its coefficient is 3, right? I minus got coefficient 3 here. In reaction, you can see it got coefficient 3. So I can write 1 by 3 into difference in the concentration of I minus. So for calculating rate of reaction, I can write 1 minus 3. For calculating rate of reaction, we can write 1 by 3 into rate of disappearance of I minus. But here we are not calculating rate of reaction, so I can write here minus delta change in the concentration of iodine, I minus iodide ion divided by delta. So this is equal to minus final concentration of I minus. So that's what's the final concentration? That's at 800 seconds. That's a 0.046, 0.046 minus. What's the initial concentration? 0.057. That's at 400 seconds. They are asking about 400 and 800, right? So the initial time is 400 seconds. So at 400 seconds, concentration of I minus 0.057 divided by delta T. So delta T is 800 minus 400. That's a 400 seconds. So this is If you are solving this, you'll get answer here. That's the minus minus become plus. So I'll write 0.057 minus 0.046 divided by 400. 7 minus 6 1, 5 minus 4 1, 0 divided by 400. 10 raised to minus 5, 11 upon 4. 4 2 are 8, 4 7 are 18, 4 7 are 28, 2 4 5 are. It's a 2.75 into 10 raised to minus 5. Okay, so that's the rate of disappearance of I minus between 400 and 800 seconds. So you can round up this number 2.75 to 2.8 into 10 raised to minus 5. So that's the answer.